if I'm interested to tell you about a distribution, so there are two type of distribution that you have already studied in S1. What were they? Sorry, normal and binomial. Let me tell you. The distribution is exactly two types. The first one is discrete and the second one is continuous. Okay. So discrete distribution, when I'm talking about a discrete distribution, so there are further types for the discrete distribution. Like first one was the binomial distribution that you have studied in S1. And the another one in S1 was geometric distribution. Okay. You must have studied that one as well. And the third one is exactly Poisson distribution. And when I'm talking about a continuous distribution, so it is exactly the normal one. What is exactly the difference between the discrete and the normal, discrete and the continuous distribution? And another one has discrete. When I'm talking about a discrete distribution or when I'm talking about a continuous distribution, so the discrete distribution always talks about the values, exact values, just like that. X can be 0, 1, 2, 3, 4, and keep on like this. And it must be the integers. Okay, it must be the integers. When I'm talking about a continuous distribution, so a continuous distribution will be defining in the range 1 to 5. So there are a lot of values and multiple values can come into this range. Okay, so these are the different exactly fact between the binomial and sorry, discrete and a continuous distribution. So when I'm talking about exactly the binomial distribution, what are the assumptions that you follow in the binomial distribution? You forgot? Actually, the Poisson distribution is exactly based on the previous distribution, so that's why I'm just calling from this one. So binomial distribution, when I'm talking about a binomial distribution, so there are a fixed number of trials to have a sense of probability of success and have a sense of probability of failure. Okay, and when I'm talking about a geometric distribution, so there are two possibilities like probability of success and probability of failure, but it will be first time of success. The geometric distribution will be done when you are just throwing a coin and first time you will get the head. That will be considered as a geometric distribution. It will be defined in the questions as well, like first time you got the head and 12th attempt, and first time you got the head and 18th attempt, that was a success. Okay, so this is exactly the geometric distribution. But when I'm talking about a Poisson distribution, so Poisson distribution is exactly having that formula for the probabilities, which is this one, exponential to the power minus lambda to the power x divided by x factorial. Got it? This is the basic assumption. And over here, lambda will be considered as the rate, and x can be the discrete number, like it can be 0, 1, 2, 3, 4, 5, something like that. Like x can be 0, 1, 2, 3, and so on. And lambda will be an average of that distribution. Okay, and some are the most important assumptions that we always follow for before every distribution. No? Like let's suppose if I'm talking about a Poisson distribution, so there are some assumptions that you should know about that thing. The first one is events occurs singularly. What is the meaning of events occur singularly? They are independent. Yeah, it is independent. The third assumption is also the independent, but the event will be a random event, and third one will be the independent event, and fourth will be an at a constant rate. These are the assumptions for that thing. Okay, let's discuss these assumptions now. Events occur singularly. Let's suppose I am sitting on a counter, and on that counter, in every particular in every minute, there will be three customers over there. Okay, got it? Events occur singularly means like every time I will just tackle only the one customer. Getting my point? I cannot treat all the three together. I just treat only one. Then after that, random events. So there is no possibility that this customer should come first and this customer should come first. Anybody can come after anyone. Okay, so there is no chance for that thing. And the independent means like the first customers will come, like it is talking to me. So it's not necessary the other customer will not come. It can be there or it cannot be. Okay, so but the rate will be constant, so it means that in every particular minute I will be treating after the completion of 1 minute I will have treated only three customers. Okay, and it can be four. So it is defined exactly by the rate. Okay, got it? Is that clear? Okay, are you writing it? Okay, I can send you as well, no issue with this. So for this thing, if I have to send, so let me make it completely. Okay, is that clear? Assumptions. Okay, what we are having in Poisson distribution, just like that when we are talking about the normal distribution, when we were dealing with the normal distribution in AS, so at that time we used to follow that assumption, like x follows the binomial distribution with n and p. Remember that? And when we have studied the normal distribution, so the normal distribution will be like that, like x follows the normal distribution with mu and sigma square. Mhm. So in this one, when we are talking about this assumption now, at that time the binomial also have the mean, and binomial also have the mean and another assumptions like the variance as well. When we were discussing about the binomial mean, so at that time the binomial mean was np and the variance of the binomial was npq. Do you remember that thing? Mm. And the same thing will be followed over here as well in the normal distribution. But when we are talking about exactly the Poisson distribution, so in Poisson distribution, the first thing is very important, that the mean of that distribution expected x will be equal to lambda. Okay, there is only one variable that we are going to treat, that is lambda. Okay, and the second thing, that the variance means v of x will be equal to sigma. And when we are talking about the standard deviation for that thing, so standard deviation will be in that case square root of lambda. Okay, so in the previous distribution you have already stated only the mean, variance, standard deviation and something like that, not more than that. Okay, you haven't discussed about the median and mod something values like this. But in Poisson distribution we always discuss about the mod as well. So the mod of the distribution, like mod of the x for that thing, there are two different cases for that. Like first one, if lambda is an integer. If lambda is an integer means there will be particular exact discrete value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. something like that. If it is an integer, there will be two different modes. Okay, if lambda is an integer, there will be two modes. So the first mode is lambda, and the second mode is lambda minus 1. Is that clear? The first, whatever the average, whatever the lambda's value, like lambda is exactly 4, lambda is exactly the average, no? Because when we are going with the assumptions, no, at a constant rate, so the constant rate was lambda exactly. It will be provided in the question. So whenever we are discussing about the mod for that distribution, so it means the lambda is exactly the mod. But if it is an integer, so there will be two different mods. First one is the lambda and second one is the lambda minus 1. For example, if we are having lambda in the question, that is exactly 6. Okay, so when we are interested to calculate the second mod for that distribution, that will be lambda minus 6, lambda minus 1, which means it is 5. So the first mod is 6 and the second mod is before that one. Okay, and when we are having, if lambda is not an integer, if lambda is not an integer, so there will be only one mod. Okay, there will be only one mod, which is exactly lambda. Okay, and furthermore, one more thing that I should mention it now. Let's suppose if lambda in this question, the lambda was 3, so the first mod, like mod number 1 of the distribution, it's going to be 3, and the second mod for that one is exactly 3 minus 1, 2. Okay, but when we are having that lambda is not an integer, so it means lambda can be 8.1, can be. No, I'm talking about a second example. Like if lambda is not an integer, so lambda can be 8.1 because if it is not an integer value. No? So remember one thing. Always in that case, always the mod will be the previous value. Like mod will be 8 over here. For example, if I'm having lambda is equals to 9.9. Okay, lambda is equals to 9.9. So in that case, the mod will be 9 only, not 10. You cannot round it up. Okay, you cannot round it up. You have to go round it before that one. Is that clear? Okay, there is one more thing which you should know. In the Poisson distribution that we are talking about, sometimes what we do, we have to go for that assumption, like we are going to add some of the two different variables together. No? You must have seen this question in the past papers, or maybe your teacher that definitely explained you, but that the explanation level was too good, you did not get one. Sometimes, sorry. Sometimes two different variables with Poisson distribution are added. For example, we have first distribution, that is x, which follows the Poisson distribution, and in which we are having lambda 1, the first variable. Okay, and there is another distribution, that is y, which is also follows the Poisson distribution, and in that case I am having lambda 2 for my variable. Okay, but when we are interested to figure out do the same things, like we are going to add x and y, like I'm going to make the distribution like this: x plus y follows the Poisson distribution. So in that case, the exact variable, treating variable will be 𝜆1 plus 𝜆2. Okay, you will add both the averages together. Is that clear? So these are the assumptions which is exactly important to be remembered. No? And one more thing which is very important. Every time in every question, you have to read that what is exactly the unit of the lambda. Okay, because the unit conversion is very important in the lambda. Sometimes you have to use a ratio before that thing, and after that you will apply the Poisson distribution. Okay, so now I am just going to pick the questions from where? Rocket device? Yeah, rocket device. Okay, so now we are going to solve the questions of the Poisson distribution. Right over here. Okay, first question that we are having. Okay, can you read the question? It is visible to you? Okay, the booklet produced by certain publisher contain on average one incorrect letter per 3000 letters. Okay, 30,000 letters, sorry. And these errors occur randomly. A randomly chosen booklet, a randomly chosen booklet from this publisher contains 12,500 letters. Use a suitable approximation distribution to find the probability that this booklet at least two errors. Okay, so we will going for the Poisson distribution for that thing, but there is a very important thing which I have just told you just before that thing, like the units for that particular thing should be same every time, no? Because they were telling you that one incorrect letter per 30,000 letters, so now they are asking about 12,500 letters, so it means the lambda will be changed for that thing. Okay, so we have to apply the unitary method in order to figure it out what the lambda should be, and after that we are going to calculate that particular thing. So over here what I will do, like if I'm interested, the mean is over here and exactly the population is over there, so 1 will be equal to 30,000 and for lambda we have 12,500. Okay, is that clear? So in this way I can just easily figure out the value of lambda by this way. So it is going to be lambda is equal to 12,500 divided by 30,000, which means it's going to be 5 upon 12, which is not exactly an integer. Am I correct? Yeah, it's an average. So it's not an integer. Definitely it is going to be the decimal number. So what if I am interested to know about the mod of that distribution? So what I will do? There will be one mod or two mod. Let me know. There will be one mod or two mod. It's not an integer, na? If it is not an integer, so it means there are going to be two different mod or one different mod. So it means you know. Yeah, exactly. Now they are asking about use a suitable approximation distribution to find the probability that this booklet contain at least two errors. Okay, at least two errors. What is the meaning of at least that you know? Probability of x is greater than equal to 2. So it means it is quite difficult to figure out that the greater than equal to 2 that definitely will going to be the infinity. So I cannot go for that thing. I will do what 1 minus probability of x less than equal to 1 because 2 was included. Yeah, less than 2 will also be the same. Okay, is that clear now? But there is one more question, that do we have the probability for 0 over here? Can we have the 0? Yes, we can have the 0 as well because it's a discrete. Discrete can have the 0 as well. So when I'm interested to know about the probability of x less than equal to 1, it means I need to know about the probability of x equal to 0 and the probability of x equal to 1. So when I'm doing that thing, it is going to be exponential to the power minus lambda, which is 5 upon 12. And what I will do, 5 upon 12 to the power of 0 divided by 0 factorial. Okay. And the another thing, what I will do, exponential to the power minus 5 upon 12, and this will be 5 upon 12 to the power of 1 divided by 1 factorial. Can I take something common from this thing? Definitely. E to the power minus 5 upon 12, and in that case, this right side, this assumption, it will become 1 exactly because it is having a power 0 and it is a 0 factorial, so it means it is going to be 1 plus this assumption, this one if I'm talking about, exponential has gone out, and 5 upon 12 to the power 1, which means it's exactly 5 upon 12, and 1 factorial is 1. So I can directly write 5 upon 12 over here. Okay, is that clear? Now I will calculate it and subtract it from 1, or I can directly place that thing. 5 upon 12, 1 plus 5 upon 12. I'm getting the probability is 0.066. Okay, 0.0661 I'm getting. This is my answer for that thing. Now I will go to the next question. The number of accidents on a certain route has a Poisson distribution with a mean of 0.4 per 50 days period. Find the probability that there will be fewer than 3 accidents during 365 days. But the point is that you have to change the value for the lambda, na, because they were talking about the 365 days and they were giving you the mean for 50-day period. Fewer than 3 means x less than 3. So first I will change that my particular assumption, like very fast, 365 lambda. So the lambda will be 0.4 divided by 50. 2.92. Lambda is exactly 2.92. Okay. And furthermore, we need the probability for x less than 3, which means I need to know the probability for x equal to 0, 1 and 2. Is it easy now? Did you get that topic? That's great. Okay, now what I can do, like every term will be having the same thing, exponential minus lambda, x is 0, so lambda to the power 0 dividing by 0 factorial plus exponential minus lambda, lambda to the power 1 divided by 1 factorial plus exponential minus lambda, lambda to the power 2 divided by 2 factorial. So it's easy for me if I take exponential minus lambda out, and that will become 1, and this will be lambda upon 1, and this will be lambda square upon 2. Okay, what is the value of lambda? That is 2.92. So exponential minus 2.92 and 1 plus 2.92 divided by 1 plus 2.92 square divided by 2, and the bracket is closed. I'm exactly getting 0.4414. Okay, so finally got the same. The probability that there will be no accident during a period of n days is greater than 0.95. So no accident mean x is equals to 0 is greater than 0.95. Find the largest possible value of n. No accident in n days. Hmm. My exactly they were asking about find the value of n. Mu? No. It's not that one. We will use the Poisson distribution network. Why should we go for that thing? Just asking. Hmm. First, we will calculate the value for that lambda, no? Because we are talking about n days, and there will be no accident during the n days. The largest possible value of n should be figured out. The number of days exactly. Do you remember when I was using over here this assumption? So at that time I was having a number of days. They're exactly asking about this number of days. What are these number of days? Okay. So here we need to first figure out the lambda by that way. Okay. The lambda. I am telling you how. Because they were telling you no accident. So what does it mean? What does it mean? That was x is equal to 0. Probability of x is equal to 0 was greater than 0.95. That was the assumption they have provided us. Okay, and when I follow that thing, exponential minus lambda multiply by lambda to the power 0 dividing by 0 factorial is great 0.95. I can easily figure out the value of lambda by this way, isn't it? So it is going to be 0.95. Now in order to figure out the value of lambda, I need to apply the ln on both sides. So it will be minus lambda, and that will be ln of 0.95. Got it? Now I can shift them. like it will be lambda is less than ln 0.95. Is that clear? Because of the sign, there is a negative sign, no? So what I did, I just shift lambda to the positive and this one to the other side. Is that clear? You must be thinking about that, why it is not having a negative. No, are you thinking about that, why it is not having a negative sign? Because when I changed the direction, it must have the negative sign, but the average cannot be negative, na? That's why I did not put the negative sign. No, if I shift the sign, that means if I'm shifting that face over here and over here, so it means it is understood that L should be having negative value, but it cannot have the negative because lambda is an average over here. Average cannot be negative, na? And in this case, it's not possible. Or when you see that when you put, if you put, in case you forgot, if you put negative over here, so you can see it is also having a negative value, 51293. It will also be like this, 0.051293. Okay, okay. So lambda is exactly this one. Now I will go for the unitary method to figure out that value. Like lambda, I know that. So there was what? There was 0.450, 0.051293, and that is n exactly the number of days. Okay, so I will go for the cross multiplication, and n will be 0.051293 multiplied by 50 divided by 0.4. I'm having n is equals to 6.411, means 12 as well if I take. So I just do the cross multiplication. So n is 6.412. So I can say that n can be, because I have to go for the integer values, and days cannot be in that way, like 6.41 days. I cannot say that. So it has to be positive, means a complete integer. So it means I can say that n will be equal to 6 over here, isn't it? So it means in less than equal to 6 days, I am going to have no accidents. Means 6 and less than 6, I will not be going to have any accidents. Okay, fine. Now it's look easier, better to understand the values, everything. That's great. So now in this question, what you see, on average, 1 in 40 microchips made at a certain factory are faulty. The number of the faulty microchips in a random sample is 1000, is denoted by x. You have took thousands over there. Okay. State the distribution of x giving the values of any parameters. State a distribution of x. So if they are following that distribution is exactly Poisson, and what should be the parameters? Hmm. Or what about that thing? If I just say, because I do not have exactly the value of lambda for my sample of 1000, isn't it? So if I'm not going to write it like a Poisson, because the Poisson must be having the exactly the parameter in the question, na? It is not having. We have to calculate that parameter, isn't it? Yeah, exactly. That's what I was saying. That's what I was saying. I was saying that if I'm writing the Poisson, so I need to calculate lambda for that thing, isn't it? Yeah. So if I am not interested to write, so what sort of distribution it is? If they are taking a sample of 1,000 and in 40 microchips there is one faulty, so I think 1 by 400 is going to be the probability of success for me, isn't it? So I can also say that the x follows the binomial distribution with n is 1,000 and the p, the probability of success, is 1 upon 400. Can I also say this? Yeah. Okay. Now state an approximated distribution x giving the values of any parameter. Now we can go for the Poisson. Approximated distribution, because the Poisson distribution is always the approximation for the binomial. Okay. In the previous case where I explained you, I forgot to just recall one thing from in your mind. Like binomial distribution was approximated to normal in AS level. You have done that thing. And binomial distribution is also approximated to Poisson distribution. Okay. The geometric is not going to have any connection with this, but the binomial little Poisson will be having in a connection in A2. So what we can do, like over here, they are asking us in part B, state an approximate distribution. So we can say that it's a Poisson distribution, and in this Poisson distribution, they are asking about the parameter value. Parameter we do not have, so we have to calculate. So first I am going to calculate the parameter, then I will write the distribution. Like 41 to 400, and lambda will be unknown for 1,000. So it is going to be 1,000 is equal to 400 lambda, and lambda will be equal to 1,000 upon 400. It will be 2.5. Hmm? Did you check it? 10 by 4, I am thinking 2.5. So it is a Poisson distribution with the variable of 2.5 is the parameter for that thing. Now use the approximating distribution to find each of the following, like x equal to 4 and x probability from 2 to 4. Okay, boss. What I can do, like for part C1, they were exactly asking about x is equal to 4. So it means exponential to the power minus 2.5 and 2.5 to the power 4 divided by 4 factorial. So I'm going to have 0.1336. Okay, is that okay? Are you there? Hello. Probability from 2 to 4. Now from 2 to 4 I have to figure out like the another probabilities from this range. It must be 2, 3 and 4. So what I can do, like they all will be having minus lambda to the power 2 divided by 2 factorial plus exponential minus lambda to the power 3 divided by 3 factorial plus minus lambda to the power 4 divided by 4 factorial. So I can again take exponential minus lambda out, and it will be lambda square divided by 2 plus lambda cube divided by 6 plus lambda 4 divided by 4 factorial is 24. Maha, you there? Hello. It's 2.5. So I am getting exactly this one, which is 2.5 square. Oh, it is exactly 0.60388. So in that case, I'm going to have the probability which is approximately 0.604. Okay, fine. Hello. There were one more part. Use a suitable approximation. In this question, they are asking, use a suitable approximation to find the probability that in a random sample of 700 microchips, there will be at least one faulty one. Okay, so the random sample of exactly 700 they are asking about, no? And wait, you were lagging on my side or your side? My side. So 2.5 was having equal to 1000, and now we are going to have it 700 for that thing, and there will be lambda is unknown for this thing. So I'm again calculating the lambda for this part. So it is going to be 2.5 multiplied by 700 divided by 1000 over here, and lambda will be 1.75 I'm getting. No, they are not asking about numbers. And we can also calculate that lambda by the unitary method of the previous question, like previous part. For example, this one. You can also follow this data as well. 1 on 400, so on 700. Yeah, like ratio. I just followed the new ratio, but it's not necessary that you will use it. You can use the first one. Okay, use a suitable approximating distribution to find the probability at random 700 magnitudes. There will be at least one faulty. At least one faulty means x must be greater than equal to 1, which means x should be probability of x is equal to 0. Okay, so what I will do, 0, it's understood that minus 1.75 will remain, and 1.75 to the power of 0, you know that it's 0, and it will be 0 factorial, so it's not worthless. Minus 1.75 directly. It is exactly 0.8262, which is approximated to 3 significant figures, so 86. Okay, is that fine up till now? Should we go to the next question or should we keep till here? Yes, boss. It's up to me. We can see another question. Like, I can explain you the question and you can try by yourself and you can tell me the answers. Oh, it's a random variable. Mm, Like, uh, but we have to do tomorrow in tomorrow's class. Then we will do the same questions because there are some more questions which is not completed because it will be a different cases over here. And this is the easier question that what I'm just sharing with you. You want that notes as well? Yeah, I will send you. So this question will be the homework. I'm explaining you this one. Okay. Okay. What is he exactly asking? That each week a sport team plays one home match and one away match. One home match and one away match. Okay. In their home matches, they score goal at a constant rate of 2.1 goals per match. Okay. In one match, they will score is 2.1 goal per match. No? It's average. It's already defined. In their away matches, they score at a constant of 0.8 goals per match. You may assume that goals are scored at random times and independently of one another, means both are independent to each other. A week is chosen at random. Find the probability that a team scores a total of 4 goals in their two matches. So it means there are two different types of probability that you are two different types of distributions of Poisson that you are going to add. Okay. The first one was Poisson, like if it is x, follows the Poisson distribution with 2.1, and the another one was y, and y follows the Poisson distribution which is exactly 0.8. But they are asking you the question of both matches, so it means they are asking of you x plus y, which is also follows the Poisson distribution, and it will be 2.1 plus 0.8. In that case, I can say that Poisson distribution will be having 2.9 over here, which means the lambda is 2.9. Is that clear? Is that clear? And they are exactly telling you that the team is okay. I was just telling that the first follows the x follows the Poisson distribution which is exactly 2.1, and y follows the Poisson distribution which is 2.8, 0.8. That is the match home matches and that is away matches. Okay, is that clear? So they are asking about the total probability. Yeah, you can take a screenshot. I am sending you the PDF. Huh? So find the probability team. Not right now. You will do it at your home, but I will send you the PDF so you can see the PDF. It will be having the last question. Okay, find the probability that a team scores a total of 4 goals in their 2 matches. So it means they both the matches are going to combine together. So in that way, I can say it like the distribution for this one and this one will be adding together. It's going to be 2.99. Now my lambda will be 2.9 for this one. Okay, and the probability is total of 4 goals. So total of 4 goals, it means they are asking you what is x plus y will be equal to 4 over here. Okay. Find the probability that the team scores a total of 4 goals with more goals scored in the home match than in the away match. Okay, so now they are asking you that the more goals in 4 matches in home matches or away matches. So what you are going to do, you are just going to calculate them separately. Okay, how will you go for the separately? Hmm. Averages. Hmm. Yeah, you can change it, and then okay, there's a fine way. You can decide it. So I will share you the answer. You will send me the solution for that one. Na? So in the before tomorrow's class, we can just proceed with this question and discuss this. Okay. And the part B, use a suitable approximation distribution to find the probability that a team score fewer than 25 goals in 10 randomly chosen weeks. So less than 25 goals, 10 randomly chosen weeks. So it means randomly selection suitable approximation to the distribution. It means now I can use exactly because we do not know because we have a margin for the 10 randomly chosen weeks. Na? We cannot say that which week they are talking about. They are not a discrete, it's a continuous. So what we can say that we will follow that, we will simplify that by normal distribution. Is that clear? It is the normal. Okay. So you will try that one, this question as well, and you will be getting the previous notes as well in the group right now. And tomorrow class, first we will discuss this question. Then we'll proceed the remaining questions. We have to do at least 15 to 20 questions with together. And after that, you will be able to solve the questions by yourself. Okay? And see you. Take care, beta. I'm sending this file. Allah Hafiz. Assalamu alaikum, this is Main. Beta, what we were doing? Past paper. Okay. Can you give me 5 minutes? Till then, I am sharing my screen. And which paper we were solving, I do not remember exactly. So we can proceed with that paper, or if we have finished. No, we haven't finished. We're at question number 13. Have you completed that paper by yourself? Definitely not.